Okay, so check your work. It looks like as we approach 1 from the left-hand side, the y values are getting closer to 2. And as we approach 1 from the right-hand side, my y values are getting closer and closer to 2. Left-hand limit equals right-hand limit. So because they're both the same, we say that the limit as x approaches 1 for this function is equal to 2. Okay, we'll come back to this. In finding the limit of a function as x approaches a, you don't ever need to consider x equals a. In fact, in this example, we couldn't. In fact, the function doesn't even need to be defined there. What matters is what happens when you get close to it. So here's a different example, sine x over x. If I did direct substitution, I'd have a 0 in the denominator and the numerator, and so I don't actually know what's happening. Try graphing that on your graphing calculators. Make sure that you are in radians mode to start with, and then let's program sine x divided by x. And let me set up my window, and I'm trying to look at what happens at 0, so I'm going to go from negative pi by 2 to positive pi by 2.
And all her friends want to wish her an extra special day, so happy birthday, Najma Sharif, from all your friends.
And I'm going to let my y values go from negative 2 to positive 2. Okay, so here's a graph of that function. And what looks like it looks like as x approaches 0, my y value gets closer and closer to 1. Of course you know it's not defined there. Of course you know there's a hole in that graph. There has to be. In fact, I think we might even be able to see it if we do this. No, maybe not. If you zoom in really closely, you'll see it. You'll definitely see it if you put in your table of values that you're going to get an error. You can't evaluate that at 0. But we don't want to. We only want to know what happens as we get close to 0. So graphically, we can see our left-hand limit is 1 and our right-hand limit is 1. Numerically, we would need to set up a table where we put in x values, we put in our function sine x over x, and then we approached 1 from the left-hand side. That is I meant to say 0. So we want our x values to get closer to 0. So negative 0.1, negative 0.01, negative 0.001, and here we have our x values approaching 0 from the left. You're going to calculate the corresponding y values.
Randall, please come to the office. Harvey and Randall.
And I think this will be enough to see our x values are getting smaller and smaller and smaller, getting closer and closer to 0 from the right-hand side. Left-hand side, right-hand side. So I'm going to pause this. You're going to calculate what you get, and then we'll talk about it.